Hi guys, this is Mrs. Ringrose, and this is my first lesson for you from home. As you told me, you wanted to start small and with the basics on logarithms, so I found this amazing packet for you guys to practice with, and hopefully this will get you ready for your online homework, which is still going to be Pearson, but I figured it lines pretty well, and it gets to what I need you guys to be able to do. If you are able to, you can print this off of Google Classroom, or you can just take notes in your notebook like you would if you're in class with me, whatever you think is going to help your learning best. So basically, logarithms can also be called the what power function. So if you're noticing these examples right here, they did the first couple for you. Whoa. I want you to evaluate each expression. It's important to be able to evaluate some of these without a calculator, so this is a good place to start. So basically, I is wanting us to figure out what power do I raise 2 to get 3. So let me see if I can write some text on here for you. All right, so there you go. There's some text for you. What power can I raise 2 to and get 8 as a result? And the answer is 3 because 2... Whoa, that's too big. Oh my God, undo. 2 to the third power equals 8. All right. So the next question you would ask yourself is, what power do I raise 3 to get 9? And the answer is 2 because 3 squared equals 9. And then the next few you would want to do by yourself, and you're basically going to set up an expression in your mind that says 6 raised to what power gives us 36, and the answer would be 2. And then you can kind of go on from there. So right now you should pause me and see if you can do these by yourself in a notebook, and when you unpause me, the answers will magically appear. Okay, here's some basic ones, and I know that you guys have a button in your TI graphing calculators that you can change a log base, and you're sort of familiar with that, but again, it's important to have some of this fact fluency, and if you can do these by just thinking it through, like for instance, Roman numeral 4 is saying, what power do I raise 2 to get 32? Just go through your powers of 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And then 2 to the fifth would be 32. Then I kind of paused here because it's really important that you are paying attention to Roman numeral 10 and below, because notice that 10, you're going from a big number 9 and you're trying to figure out how to get 3. Well, I know that the square root of 9 equals 3, and so I need to be able to express the square root of 9 as a number. And we learned in Algebra 2 that radicals can be expressed as an exponent, that's a fraction. So I know that 9 raised to the 1/2 power is going to give me 3. And again, that's because the square root of 9 is 3. So again, what power can I raise 5 to get radical 5? And again, the answer is 1/2. What power can I raise 1/2 to get 1/8? Well, I know that 2 cubed is 8. So if I can raise the 1/2 to a cube, I will also get 1/8. So that answer is 3. All right, if you have any questions yet, just pause me, write down your question, and then you'll be able to ask me some questions in a forum type setting, or via email or remind text. What power do I raise 42 to get, let's see, what did I just do? Sorry about that. What power do I raise 42 to get 1? Well, we know that anything except for 0 raised to the 0 power is going to give me 1. So that's our justification for answering Roman numeral 8 as 0. And then what power do I have to raise 102 to get 0.01? So we're basically looking to see, how can I make that number a decimal? Well, hopefully you remember that negative exponents will get me some sort of fraction. So if you can recognize this as this fraction, right, because that's 100th, we say when we see a decimal like that as 1/100th, then we can raise 100 to the -1 power, and that will reciprocate that number. So the answer for, geez, what is that, 14 is -1. All right, and then finally, we have another one that's being turned into a fraction. So what power can I raise 2 to get 1/4? Well, I know that 1/4 is 2 squared. And I'm sorry, I know that 4 is 2 squared. And then I need to reciprocate it. So the way I'm going to raise 2 is by making this a negative exponent again. All right, so again, pause me if you need more help. Now's a good chance to write your questions or asterisk something, and I'll make sure I can help you guys as much as possible. All right, so on to the next page. If you want to take a second to write that one down or think about it, we're trying to go from a fraction and we want to reciprocate it and get it into as a not a fraction, as an integer. So how can I first of all make 1/4 turn into, like, for instance, 4? Well, I can reciprocate that by using a negative exponent. 1/4 to the -1 power is going to turn that fraction around and give me 4. But I don't just want 4, I want the square root of 4. So I'm going to also need to put in that 1/2, because 4 to the 1/2 power is the same thing as the square root of 4, which is equal to 2. So my answer on this one is going to actually be -1/2. And again, that's because we want to make sure that we're reciprocating 1/4, and we are also taking the square root of it. So basically the what power function, where b is a number, you can write something like is the number you need to raise your base in order to get x. So if you know that b raised to a certain power is equal to x, then what power b of x equals L, right? So there's a couple of other examples for you to try on your own. So again, if you want to pause me, and then when you unpause me, all the answers will magically appear. I just want to make sure that you're doing some check-ins with yourself to make sure that this is making sense. All right, so these are a really good checkpoint for yourself because of all the ones that have no answer. So I really hope that you took the time to try these out. And if you didn't take the time to try them out, pause me and go back and try these. You guys, we've kind of talked about domain and range on logarithmic expressions already. We know that the range is going to be all real numbers. As you can see, like, we're getting fractions. If it's going to be radical, we're getting negative numbers. But your input cannot be 0 or smaller, because, you know, we kind of studied the graph a little bit before we left. There's an asymptote at x equals 0, and there's nothing that goes below it. Now, number 5 works as an expression when we're evaluating, because -2 can be raised to an even exponent and get an even answer, but it's not going to work as a graph. Like, I can't graph the function, you know, log base -2 of x, because we typically don't, you know, are not going to look at negative bases. This is just to get you thinking. Okay, so moving right along, number 9 basically kind of wants you to write down in words the question that I just talked about. What kind of values can the base be? And we can make this into a function by saying, you know, f of x is the what power. So you guys have seen logs before, so we're going to change this notation up, and instead of saying what power, we're going to say log base b of x, right? So your following examples is, you know, actually, we don't even have to post this as an assignment. I don't know why I said that. That was stupid. These are the same exact questions as we just did, except now we're changing the notation. So number 1, log base 2 of 8 is 3. Number 2, log base 3 of 9 is 2. And again, that's because 3 squared is 9. Number 3, the log base 6 of 36 is, and you can, you know, fill these in or kind of make a mental note. So Number 10, we can compute the value of each logarithm, and we can verify our answers using an exponential statement. So we know that the answer is 5 because that was on the previous page. And then basically we want to change this into an exponential statement or notation, which is we're going to rewrite it 2 to this power gives me 32. So I just want you thinking about justifying your answers. Okay, guys, I will post this one as an assignment in Google Classroom. I think I have this available as a Word document, which I can easily convert to Google Doc, and you can just type your answers in and send it back. All right, so, and here's your problem set. Again, if you want to be able to print this off of Google Classroom, go for it. If you want to, you can just do a couple in your notes. I'm not going to hold you to this one because you're going to see similar questions on your Pearson online homework. And if this is really easy for you, I don't want you to have to do it twice. But feel free to try this if you need more practice. All right, so I'm going to say this one is optional. And let's see, can you do all these? All right, so we talked about rewriting, and then we talked about evaluating. So base 2 is a pretty common base. You're going to see a lot of base 2s and a lot of base 10s and a lot of base E's. So you might want to, really sit down and think about committing a lot of these to memory. Just a thought, like you had it memorized your multiplication facts at some point. Let's see. Oh, and then some base 3 just for added practice. All right, so again, this is all optional, like probably 6 you want to skip over. 7 and 8 are really good thinking questions because, that's why we're here in Honors Pre-Calc. Number 9, we are going to talk a lot about the properties of the properties of logarithms. But just to get you thinking about how these would look is, so number A, what you can do is, at this time, is just straight up evaluate it. And so we know that log base 2 of 8 evaluates to 3, and we know that log base 2 of 4 evaluates to 2, and we know that log base 2 of 32 evaluates to 5, and we also know that 3 plus 2 is 5. So we basically just verified number 9. So if you want to take the time to do B, C, and D, I think that would be a really good idea. Number 10, again, we're going to learn these properties explicitly, but you may have noticed that 8 times 4 is actually equal to 32, and so that's going to be the property that we're going to learn on another lesson. And then 11 and 12, you should be able to do those by using your properties of exponents and some basic facts. All right, so to summarize. All right, so this is my final slide. I don't know if we like the legal pad yellow, but here we go. So check off the things you can do. These are the things that you probably actually learn in Algebra 2, but if not, it's our second chance to really understand it. Rewrite logs into exponential notation. Rewrite exponential notation back into logarithmic notation. And evaluate simple log expressions with and without the calculator, like we did all throughout this video, so that we really understand what logs are asking. This is how you're going to show me what you've learned. Click on the classwork link on Google Classroom and answer the questions from exercise 10. And if you were able to print this packet and you prefer to handwrite answers in, you can take a picture of your work and post it in Google Classroom, and that'll work too. I just need, me, I just want to know some evidence that you're learning. And that way I can give you immediate feedback before you go and try your online homework, because your online homework is aligned to your textbook, and it's going to be a little more difficult because there's going to be some stuff with E. So don't forget that, if you see this basically just means the same thing as log base E. So don't be afraid. You got this. And as always, I'm here for you, so send me any questions you may have. And I miss you guys, and I hope to see you soon. Bye.